Rising energy demand and depleting resources of conventional crude oil turn attention toward the vast global resources of heavy oil and bitumen. Although known heavy oil resources are abundant, worldwide production has been constrained by key technical and economic challenges. Ivanhoe Energy's innovative, proprietary, and patented HTL field upgrading process addresses the challenge of heavy oil development and has positioned the company at the forefront of the global heavy oil opportunity. HTL, or heavy to light, is an upgrading process which converts heavy viscous crude oil into a lighter, transportable, and more valuable synthetic crude oil. HTL captures the market value differential between heavy and light oil by eliminating heavy oil residue and dramatically reducing viscosity. The HTL processing plant can be located upstream, at or near the wellhead, fully integrated with field operations. Alternatively, midstream HTL can upgrade heavy oil from onshore and offshore resources for supply to refineries with limited residual oil capacity. HTL supplies its own energy needs by converting byproduct coke and gas into heat, sustaining the upgrading process. Only a small fraction of energy available from coke and gas is consumed within HTL, and excess energy is converted into steam or power. When integrated with field operations, HTL supplies high-pressure steam for thermal recovery methods such as SAGD. With midstream HTL, excess energy is exported as electrical power. HTL frees the heavy oil producer of logistical and economic barriers associated with external supply of natural gas and diluent. HTL is a thermal conversion process and, unlike other upgrading technologies, does not require catalyst or consume hydrogen for hydroprocessing. Conventional upgrading facilities require massive operating volumes to be economic. The efficient design of HTL's conversion process and elimination of costly hydroprocessing units provide HTL with a unique competitive advantage. HTL lowers the per-barrel construction and operating cost of heavy oil upgrading, and facilities are economic at greatly reduced scale. HTL provides a solution to each of heavy oil's challenges. Upgraded oil is more valuable than raw heavy oil and can be transported in pipelines without addition of diluent. HTL produces energy for field operations, and facilities are cost-effective at smaller scales than conventional upgrading. HTL represents an innovative approach to a time-tested concept: thermal cracking of large hydrocarbon compounds in heavy oil to lighter, more valuable products. The key innovation is speed, the control of processing times to a few seconds, significantly faster than conventional methods such as coking. This is the core of the HTL process: a closed loop of fluidized sand circulating between a reheater, in which sand is elevated to very high temperatures, and a reactor where hot sand and feedstock are rapidly contacted. At its heart, HTL is a simplified version of a conventional oil process known as fluid catalytic cracking, or FCC, extensively used in refineries to convert gas oil into transportation fuels. In front of the core process, conventional distillation separates heavy and light fractions of the raw feedstock. Heavy fractions are forwarded to the reactor for conversion. Lighter fractions are transferred directly to product storage, maximizing yield of liquid product and reducing core equipment sizing. In the core section, hot sand from the reheater is transferred to the bottom of the reactor, where lift gas propels the sand up the riser. Here, heavy oil is sprayed into the reactor through a simple nozzle, efficiently dispersing feed across hot sand in the mix zone, depositing a thin film of feedstock onto the sand grains. As sand particles travel up the reactor riser, rapid heat transfer instantly vaporizes the thin film of feedstock. Large hydrocarbon compounds are broken apart, releasing lighter products into the reactor vapor phase. When the sand particles reach the top of the reactor, only a thin film of carbon-rich coke remains on the sand. Coke deposition removes excess carbon from the feed, enhancing value and reducing viscosity of the liquid product. Coked sand, reactor product vapors, and lift gas exit the top of the reactor and are separated by a conventional cyclone. The reactor vapors are immediately cooled or quenched, ceasing further thermal conversion, then forwarded to the product heat recovery and separation system. The thin layer of carbon-rich coke is efficiently combusted from the sand with air in the reheater. This releases a substantial amount of valuable energy, sustaining the reactor's heat demand, and also supplies significant excess energy recovered as high-pressure steam in the sand coolers. Byproduct coke is completely consumed within the HTL process, contrasting with conventional coking, which produces high volumes of low-value petroleum coke. HTL eliminates the need for expensive coke handling facilities or transportation of coke to distant markets. In the reheater overhead system, the waste heat boiler cools combustion product gases and generates additional high-pressure steam. Unwanted flue gas emission products are captured and removed in the flue gas desulfurization unit. In the product fractionator, reactor vapors are further cooled and condensed. Liquid product is blended with distillate from the feed distillation towers, producing synthetic crude oil. Non-condensable gas is collected overhead of the product fractionator, compressed, and recycled as lift gas to the base of the reactor. Net gas generated in the reactor is forwarded to fuel gas, where energy is utilized to supply the feed distillation heat load and generate additional high-pressure steam. All components of a commercial HTL facility are either standard, non-licensed processing units, or in the case of the core hot section, an adaptation of proven technology in use at refineries worldwide. Like other successful leading-edge technologies, HTL was developed, proven, and commercialized for another industrial application. Ensign, a Canadian company, first exploited the core technology in the 1980s, successfully developing an ultra-fast version of a thermal conversion process known as pyrolysis. Ensign's commercial installations convert wood and other biomass residues into renewable liquid fuels and chemical products. In 1998, Ensign adapted its technology to upgrade heavy oil, building a pilot facility near Ottawa, Canada. Remarkable results were attained at the pilot facility, compelling the construction of a 1,000-barrel-per-day commercial demonstration facility, or CDF, located near Bakersfield, California, in the Bell Ridge heavy oil field owned by affiliates of ExxonMobil and Shell. CDF testing operations were initiated in 2005, aimed to validate pilot facility results at a large scale, with a focus on proving the scalability of product quality and yields. A comprehensive slate of different feedstocks were processed through the CDF, including a range of heavy oils from California, Latin America, and Athabasca bitumen from Western Canada. The CDF has successfully completed its mission of confirming process scalability. The results have been utilized for design and engineering of full-scale commercial facilities. Having proven large-scale operation of HTL, Ivanhoe Energy constructed a new generation state-of-the-art long-term testing facility in San Antonio, Texas. This HTL processing unit, called the Feedstock Test Facility, or FTF, has all the functionality of a full-scale commercial facility, but with a manageable capacity. The FTF allows for multi-run optimization and testing of third-party crude oils from around the world. The FTF comprehensively simulates the complete HTL commercial process from feed distillation through the core reactor section and on to the product recovery system. The Feedstock Test Facility was constructed in modules by Zeton, an Ontario-based world-leading designer and builder of modular test plants and small commercial facilities. The FTF not only allows Ivanhoe to accurately estimate the commercial processing characteristics of target crudes, but also provides important data for the design and engineering of full-scale plants. The FTF is facilitating the generation of intellectual property, including development of new patents and operational know-how. Having completed development, scale-up, and testing operations, Ivanhoe Energy is now engaged in the design and engineering of full-scale HTL facilities for deployment to its own heavy oil projects. Ivanhoe Energy's HTL Technology Center, located in Houston, Texas, comprised of professional experts with significant experience encompassing all phases of downstream operation, design, and technology implementation, has recently completed HTL front-end engineering and design for the company's initial heavy oil Tamarack project in Canada, along with conceptual evaluation of other potential HTL projects. Engineering details developed for the Tamarack project, including the production of a three-dimensional design model, are being utilized as a blueprint for rapid deployment of engineering and design to other commercial HTL projects. With an initial focus on oil sands in the Athabasca region of Western Canada, additional HTL upgrading projects are being evaluated for Latin America and elsewhere around the world, supported by continued technical and economic confirmation of competitive advantages offered by HTL in heavy oil development. HTL enables viable exploitation of heavy oil and bitumen reserves where economics are otherwise challenged, and where environmental and transportation constraints prevent the development and marketability of heavy crude oil. HTL is a simple, efficient, and elegant solution for field-integrated or midstream upgrading, and allows Ivanhoe Energy to maximize stakeholder value in development of global heavy oil resources. Ivanhoe Energy and HTL, solving the challenges of heavy oil.